Alright, you guys, this video is about the first part of section 1.7, so I'm calling it 1.7a, and you are going to need a separate sheet of paper because I do need you to write down some important theorems that we'll be using moving forward in our geometry class. So our first theorem is the vertical angle theorem, which simply states that vertical angles are congruent, and it shows you an example of two lines that have intersected to form four angles. And vertical angles truly just means the angle across. So angle 3 is congruent to angle 4, and I did not mean to just write over that. But 3 is congruent to 4, 1 is congruent to 2. And by the definition of congruent, that means they have the same measure. We're going to be writing this theorem a bunch, and we don't want to handwrite the whole thing. So our short form is going to be the vertical angle theorem. Vert-ang-them. That is how we will abbreviate this. Let's move on to our next one. Remember to pause and write these down and then come back and hear me talk about them. The congruent supplements theorem states that if two angles are supplementary, which we remember that supplementary means that they, add to be 180 degrees. If they are supplementary to congruent angles or to the same angle, then they are congruent. And our diagram here kind of clarifies that for us. It says if the measure of angle 1 and the measure of angle 2 add to be 180, and also if the measure of angle 3 and the measure of angle 2 add to be 180, then we can confidently concur that angle 1 is congruent to angle 3, which means it has the same measure. So that congruent supplement theorem, if I'm going to write that short, I'm going to write our congruent symbol, congruent sup theorem. And similar to the congruent supplements theorem is the congruent complements theorem, which is almost basically stating the same thing, except for that we're dealing with angles that are complementary, which means they add to be 90 degrees. But if angle 1 and angle 2 add to be 90, and angle 3 and angle 2 add to be 90, then angle 1 must be congruent to angle 3. And in short form, I would write that as the congruent, with our congruent symbol, complementary theorem. Our next couple theorems are pretty straightforward. All right angles are congruent, so if you have two angles that are right angles, then their angles are congruent, which then means their measures are the same. And we can write that as right RT angle, so an angle symbol, are congruent, a congruent symbol. And then our next one tells me that if two angles are congruent and supplementary, so they add to be 180, then each is a right angle. So if you have two angles that are congruent and they add to be 180 degrees, then they have to both be right angles. And if we think about that, that kind of makes sense because there's no way we could add two things that are the same in total to be 180 besides 90 plus 90. So in short form, this would be congruent and supplementary. I'm going to introduce you a new symbol. It's going to be like an equal sign with an arrow. Therefore, that's kind of what then, if this, then that, then they are right angles. Okay, that's all your definitions or your theorems. Oh, just kidding. There's one more. It's a big one. I can't believe I forgot it. I got excited to move on. The linear pairs theorem. This is one you'll probably use a lot. It's the sum of the measures of a linear pair is 180 degrees. So a linear pair, angle 1 and angle 2 form a linear pair because we have a line right here. And they are two angles that are formed from that line. Angle 1 and angle 2. So together they form a linear pair because they add up to be 180 degrees. The measure of angle 1 plus the measure of angle 2 equals 180 degrees. And that's just our formal theorem for that. And you can abbreviate that as the linear pair theorem. Okay, now I need you guys to get out your workbook and we're going to apply those theorems, and this is what I wanted to spend our time on. If you open up your workbook to page 52, we're going to look at example 2 to start. I know we're skipping some things, but I'm trying to do this in an order that actually will make sense rather than the order this book goes in sometimes. And we're going to apply the vertical angle theorem, and that is how we're going to solve these next two problems. Just a reminder, the vertical angle theorem was something we just covered that tells us that vertical angles are congruent. And we know that if something is congruent, that means that they have the same measure. So now let's look at this example here. It says find the value of x and the measure of each labeled angle. So we're going to need to do three things. We're going to need to find x. Then we're going to need to find 6x minus 45 degrees. And then we're going to need to find 4x plus 5 degrees. Because it didn't actually label these angles. They just gave us their 6x minus 45, their kind of mathematical equation or expression. So now we're thinking, how can we find x? How can we solve for x? We don't even have an equation here. That's where we're going to use what we know about vertical angles. And we can see that these two angles are directly across from each other. They are vertical angles. And what we just learned in the vertical angle theorem tells us that vertical angles are congruent, which means that they have the same measure. And if something has the same exact measure, then it is equal. So we can say confidently that 6x minus 45 is going to be equal to 4x plus 5 because of that vertical angle theorem. And now we can use our algebra skills to solve this. And we're going to subtract the 4x from both sides, and you end up with 2x minus 45 equals 5. If you add the 45 to both sides, you end up with 2x equals 50. If you divide by 2, you end up at x equals 25. Awesome, we did one of the things. Now we can use that. It's going to be 6 times 25 minus 45. I'm going to substitute in first just because that is what I want to do first. And now I'm ready to simplify to figure out the measure of both of these angles now that we know the value of x. So 6 times 25 minus 45 is 105 degrees, and 4 times 25 plus 5 is also 105 degrees. Is it a coincidence that they were the exact same measure? No, not at all. Knowing that they're vertical angles and that vertical angles are congruent, they should be exactly the same. So that lets us know that we did our math right, because they did check out to be exactly the same. You're going to try part B in your book, and I am going to delete these text boxes and you try them. All right, so hopefully you set them equal to each other. And did you find that x equals 19? Did you substitute 19 back in? Did you find that the measure of both of the angles was 132 degrees? Check that work and figure out where you went wrong if not. All right, the last problem we are going to do together is actually if you turn the page, and it is at the bottom, and it is do you understand number 4, and it's going to make us apply some reasoning. So we see we have a diagram. I'm going to read the problem and then use the diagram to fill in anything that I know. So it says if angle 2 and angle 3 are complementary, how could you use the vertical angles theorem to find the measure of angle 1? Well, what does complementary mean? They add up to be 90. So let's write out what we know. We know that the measure of angle 2 plus the measure of angle 3 is going to be 90 degrees. And now it's asking us something about the vertical angles theorem. So let's see, do we have vertical angles? We know that this angle is 30. So what other angle has to be 30 degrees? Angle 2. It needs to be 30 degrees. Okay, cool. But we're looking for angle 1. Angle 1, though, is directly across from angle 3. And we know that angle 2 plus angle 3 equals 90 degrees. So if we can find angle 3, then we also know angle 1. And that's exactly what we're going to do. We're going to substitute the measure of angle 2, which is 30 degrees. So we end up with 30 plus the measure of angle 3 equals 90. And from subtraction, we can find that the measure of angle 3 equals 60 degrees. So now we know this is 30, this is 60, so what must this be? 60. And we know that because the measure of angle 1 is equal to the measure of angle 3 because they are vertical angles. Therefore, the measure of angle 1 must be 60 degrees because of that vertical angle theorem where the vertical angles are congruent. So you've got some practice before you move on to the second part of this lesson, which is proofs. Do your practice problems. It's going to have you use the reasoning of vertical angle theorem.